Now we have to see some examples. Here, the first example is that a ladder 15-meter long reaches a window which is 9 meter above the ground on one side of the street, keeping its foot at the same point. The ladder is turned to other side of the street to reach a window 12-meter high. Find the width of the street. If we observe the figure, it is seen that AB is the road and AD is the height of the building and D is the window of that building. From the point C, a ladder DC or CD is the ladder or length of the ladder, and it reaches the window D. Now, from the same point C, the ladder is turned to the another side of the street so that it reaches the window E of the second building, and in this way the height of the first building or the height of the means the window is at 9 meter from the ground. Here the second window is 12 meter high from the ground, and we have to find the length of the road, that is AB is the road, so we have to find the length of AD. Here, to solve this example, let AB be the width of the street and C be the foot of the ladder. Here AB is the street or road and C be the foot of the ladder, and D as well as E be the windows at heights 9 meter and 12 meter respectively from the ground. Then CD and CE are the 2 points of a ladder. Then first of all we will consider the triangle ACD. Here triangle ACD is a right angle triangle because this angle is right angle. Here by Pythagoras theorem we can write CD square is equal to AD square plus AC square or AC square plus AD square. Here CD is 15, so 15 square is equal to, we don't know the length of AC, so we have written here AC as it is, plus AD is 9, so 9 square. Now 15 square is AC square is equal to 15 square minus 9 square. 15 square is 225 minus 9 square is 81, and therefore CD square is equal to 225 minus 81, that is equal to 144. And therefore, taking square root on both sides, we get CD is equal to 12 meter. Again, we have to consider the another right angle triangle CBE, and applying the Pythagoras theorem, we will get CE square is equal to CD square plus BE square. Here CE is again, that is the length of the ladder is 15 square is equal to CD square as it is plus 12 square. So CD square is equal to 225 minus 12 square is 144. So 225 minus 144 it will be again 81, and therefore taking square root on both sides we will get CD is equal to 9 meter. And now to find the width of the street, that is AB equal to AC plus CD. AC plus CD. we know that AC is 12 and CB is 9. So 12 plus 9, that is equal to 21 meter, and that is the length of the street. So by applying the Pythagoras theorem here, we have solved the first example. Now we will see the second example. Here P and Q are midpoints of the sides. Here P is midpoint of AC and Q is the midpoint of BC. So P and Q are the midpoints of the sides CA and CB respectively of triangle ABC, which is right angled at C. Means C is the 90-degree angle, and therefore prove that first 4AQ square is equal to 4AC square plus BC square. Second question is 4BP square is equal to 4BC square plus BC square, and the third one is 4AQ square plus BP square, and that is equal to 5AB square. So here, you know, AQC, this is one right angle triangle. BEC, that is one more triangle. Then PQC, third triangle, and our original triangle, that is ABC. So 4 triangles are there, but out of we have to select first triangle AQC, means AQC, and in a right angle triangle AQC, by applying Pythagoras theorem, we will get AQ square is equal to AC square plus QC square. AC square plus QC square. So here multiplying by 4 on both the sides of the equation means 4AQ square is equal to 4AC square plus 4QC square. Means that is our adjustment. And now here 4AQ square as it is, 4AC square also as it is, plus here square root of 4 is 2, square root of QC square is QC, make bracket and then square, because 2 square is 4 and QC square is here. So here 2QC. Now if we observe the figure, it is seen that D between S, Q between S, C, D between S, Q between S, C, and therefore DQ plus QC is equal to BC, and therefore we know that Q is the midpoint of BC, and therefore we can write here DQ is equal to QC. So instead of DQ I have written here QC plus QC, that is equal to 2QC, and 2QC is equal to BC. So I will remove 2QC from here and I will write the value, that is 2QC is equal to BC. So we will get 4AQ square is equal to 4AC square plus BC square. In this way, we have proved the first question, that is 4AQ square is equal to 4AC square plus BC square. So this is our first answer. Now, according to second question, we have to consider the triangle BPC. And now this is also a right angle triangle. By applying Pythagoras theorem, we will get BP square is equal to BC square plus CP square. Again, by multiplying both sides by 4, we will get 4BP square is equal to 4BC square plus 4CP square. Again 4BP square as it is, 4BC square as it is, square root of 4 is 2, square root of CP square is CP, and then squaring the bracket we will get 2CP bracket square means 4CP square. Here we know that A between S, B between S, C, A between S, B between S, C, and therefore AB plus BC or CP is equal to AC. Again we know that P is the midpoint of AC, so AP is equal to PC. Here removing AP, we will write here CP plus CP, it will be 2CP. So 2CP is equal to AC. Here we will remove 2CP and put there AC. So we will get here 4BP square is equal to 4bc square plus ac square. In this way, we have proved the second question, that is 4bp square is equal to 4bc square plus ac square. Now here adding equation 1 and 2, if we consider equation 1 and this is equation 2, and adding we get here 4aq square plus 4bp square is equal to 4ac square plus bc square plus 4bc square plus ac square. Here 4ac square plus 1ac square, it will be 5ac square. Again 4bc square plus 1bc square, it will be 5bc square. And now taking 5 as a common, we will write 4aq square plus bp square is equal to 5 into bracket ac square plus bc square. Now if we observe our original triangle, that is triangle ABC, in a triangle ABC, here C is the right angle, so AB square is equal to AC square plus BC square, AC square plus BC square. Here we have applied Pythagoras theorem, means AB square is equal to AC square plus BC square. Here AC square plus BC square is equal to AB square. Instead of this bracket, we will write here 5ab square. In this way, we have proved here 4aq square plus bp square is equal to 5ab square. And now we have to see the third question, and same figure here is given, but the question are different. Here in a triangle ABC, angle B is equal to 90 degree. Let B and E be any point. Here P and Q are midpoints, but here B and E are not the midpoint. They are any points respectively on AB and BC. Then prove that AE square plus CD square is equal to AC square plus DE square. Now in a right angle triangle ABE, we will consider first ABE. So ABE, and applying Pythagoras theorem, we will get AE square is equal to AB square plus DE square, equation number 1. Now in a right angle triangle DBC, we will apply the Pythagoras theorem. We will get CD square is equal to DB square or BD square plus BC square. This is equation number 2. Adding equation 1 and 2, we will get A square plus CD square is equal to AB square plus BA square plus DB square plus BC square. Here AB square and BC square are taken together into a bracket, and B square and BD square are taken together. So we will get A square plus CD square is equal to AB square plus BC square plus B square plus BD square. That is equation number 3. Now in a triangle ABC, here our original triangle ABC, by Pythagoras theorem we will get AB square plus BC square is equal to AC square. And in a triangle DBE, that is the smaller triangle DBE, again by applying Pythagoras theorem we get here B square plus BD square is equal to DE square. So that is equation number 5. Now from equation 3, 4 and 5, 3, 4 and 5, sorry, from equation 4 and 5, equation 3 becomes here A square plus CD square is equal to AB square plus BC square means AC square plus here B square plus BD square, it will be DE square. So A square plus CD square is equal to AC square plus DE square. In this way we have proved the required equation, that is a square plus cd square is equal to ac square plus d square. Some examples based on the property of Pythagoras theorem, converse of Pythagoras theorem, as well as some properties of similarity we have solved. Now we have to solve some more examples here. Here the example is that, first example, in a triangle ABC, angle C is equal to 90 degree. Angle C is 90 degree means triangle ABC is a right angle triangle. Let BC is equal to A. Here BC is equal to A. CA is equal to B. This CA is equal to B. Then AB is equal to C. Means the hypotenuse, length of the hypotenuse is C. And let P be the length of the perpendicular. P be the length of the perpendicular from C arm AB. Here from CD is the perpendicular drawn which intersects the hypotenuse AB in a point D. Therefore, BC is P, in small p. Then prove that CP is equal to AB. We have to prove that CP is equal to CP is equal to AB. And the second question is 1 upon P square is equal to 1 upon A square plus 1 upon B square. Here in a triangle, right angle triangle ABC, CD is perpendicular to AB, and therefore CP is equal to, or CD is equal to P. CD is equal to P, and therefore area of triangle ABC is equal to, we know the formula for the area, that is 1/2 base into height. Here we can find the area of triangle ABC by two ways. Means first, here if we consider that CD is the height and AB is the base, then we can write or find the area triangle ABC is equal to 1/2 into base is AB and height is CD. So AB into CD, that is equal to 1/2. AB is C and CD is P. So 1/2 CP. Now by another method we can find the area of triangle ABC, that is here right angle is there and the two sides making right angles, out of which the one side is base and the another is height. So BC is the base and AC is the height. So area triangle ABC is equal to 1/2 BC into AC, 1/2 BC into AC, that is equal to 1/2 BC. BC is A and AC is B, so 1/2 AB. Here if we consider the two equations, then our LHS, that is area triangle ABC and area triangle ABC, LHS of both the equations are same and therefore RHS must be same, and therefore from 1 and 2 we can write that 1/2 CP is equal to 1/2 AB. Here 1/2 CP is equal to 1/2 AB. Here 1/2 will get cancelled and then we will get CP is equal to AB. CP is equal to AB. Here which is the our required answer. That is, we were asked to prove that CP is equal to AB. In this way, we have proved here that CP is equal to AB. Now, to prove the second question or second, that is 1 upon P square is equal to 1 upon A square plus 1 upon B square. Again, we will consider that triangle ABC is a right angle triangle and angle ACD or angle C is equal to 90 degree. If ABC is a right angle triangle, then definitely we can apply the Pythagoras theorem here. Therefore, triangle ABC is a right angle triangle, angle C is equal to 90. Therefore, by Pythagoras theorem we can write hypotenuse, side opposite to right angle is hypotenuse, that is AB square is equal to square, sum of the square of the two legs, that is BC square plus AC square. So AB square is equal to BC square plus AC square. But we know that AB is equal to C. So C square is equal to BC is equal to A square plus AC is equal to B. So we will get here C square is equal to A square plus B square. But from equation 1 we have proved that CP is equal to AB. We know that CP is equal to AB and therefore C is equal to, here P is multiplying to C, so it will divide. So C is equal to AB upon P, means P will divide to AB. So C is equal to AB upon P. Now substituting the value of C here in equation 2, we will get here C square is AB upon P bracket square is equal to A square plus B square, and it will imply that is A square B square, because square of bracket is there. So A square B square divided by P square is equal to A square plus B square. And now if we divide or A square B square, here we can multiply it by 1. Here if you multiply, then A square B square is multiplied, it will divide at the another side. So we will get 1 upon P square, because it will, here 1 will remain only, 1 upon P square, and A square B square will go to the denominator of the term at the right hand. So here 1 upon P square is equal to A square plus B square divided by A square B square. And now we can write 1 upon P square is equal to, here A square B square is dividing to A square as well as B square. So we can write the denominator separately. So we can write here 1 upon P square is equal to A square upon A square B square plus B square upon A square B square. Here A square will get cancelled. Similarly, in the second term we will get B square cancelled, and then we will get here 1 upon P square is equal to 1 upon B square plus 1 upon A square, or we can write 1 upon P square is equal to 1 upon A square plus 1 upon B square. So that is our second required answer, that is 1 upon P square is equal to 1 upon A square plus 1 upon B square. In this way we have solved here the first question. Now we have to solve the second question. Here it is given that prove that 3 times the square of any side of an equilateral triangle is equal to 4 times the square of the altitude. Means triangle ABC is given here equilateral triangle. It is given that triangle ABC is an equilateral triangle, and we have to prove that the square of any side, for example, Square of means 3 times the square is 3ab square is equal to 4 times the altitude. Altitude means height of the triangle. Here AD is the height. AD is the height. So 3ab square is equal to 4ab square we have to prove. And now here ABC is an equilateral triangle, means AB equal to AC equal to BC, means all the three sides are equal, and from the vertex A, AD, that is altitude AD is drawn, which intersects side BC in a point D. Now we know that the altitude is the bisector of the opposite side, means D is the midpoint of BC, means AD intersects side BC in its midpoint D, and therefore BD equal to DC, or BD is equal to 1/2 BC. Here in a triangle ABC or triangle ABC is an equilateral triangle and AD is perpendicular to BC. Now, due to this altitude, our triangle ABC, original triangle, is divided into two triangles, that is triangle ADB and triangle ADC. Here we know that since triangle ABC is an equilateral triangle, then AB equal to AC, we can write here AB equal to AC, means side of triangle ADB equal to side of triangle ADC. Similarly, we know that all the angles of the equilateral triangle is of 60 degree, means it is all the angles are equal. So we can write here angle B equal to angle C. Also here it is given that AD is perpendicular, so angle ADB is 90 degree. Similarly, angle ADC is also 90 degree. Means both the angles are of 90 degree. So the corresponding angles are equal. Here it is seen that the two sides, means the two angles of one triangle are equal to corresponding two angles of the other triangle. Similarly, the one side of one triangle is equal to another is equal to corresponding side of another triangle. So here we can say that by triangle ADB, congruent triangle ADC, here we can say that AA SAA criteria, SAA congruent criteria, means the two angles of one triangle are equal to corresponding two angles of another triangle, and the side which is not included by these two angles are equal. Therefore, by SAA criteria, both the triangles are congruent. Here, if both the triangles are congruent, then the corresponding side, that is CPCB, BD equal to DC. So BD and DC are equal, and if BD and DC are equal, then D is the midpoint of BC, and we can write here BD equal to DC, and that is equal to 1/2 BC. So BD equal to DC is equal to 1/2 BC. And now in a triangle ADB, which is a right angle triangle, we can apply Pythagoras theorem. So we can write AB square is equal to AD square plus BD square. AD square is equal to AD square plus BD square. That is equal to AB square is equal to AD square plus, instead of BD we will will substitute its value. BD is equal to 1 half BC. BD is equal to 1 half BC. So 1 half BC bracket square, and therefore AB square is equal to AD square plus BC square upon 2 square is 4. So BC square upon 4. Again here at the RHS for the addition, no denominators are same. So we have to cross multiply. Then we will get here AB square is equal to 4AD square plus BC square divided by 4 ones are 4. Here 4 is dividing, it will multiply AB square. So we will get here 4AB square is equal to 4AD square plus BC square. 4AD square plus BC square. But we know that here BC is equal to AB because our triangle is an equilateral triangle, and therefore all the sides are equal. Therefore BC is equal to AB. Here we will remove BC and put the value AB instead of BC. Then we will get 4AB square is equal to 4AD square plus AD square. Now if we take AB square to left hand side, it will subtract. So 4AB square minus AB square is equal to 4AD square, and subtraction will be 3AB square is equal to 4AD square. In this way we have proved that the 3 times the square of any side of an equilateral triangle is equal to the 4 times of the square of the altitude. So that is our answer. And now we will see one more question. Here some part of the question we have studied in last year, that is in Hero's formula. Last year we have seen and we have derived the area of an equilateral triangle. Last year we have seen. Today we are going to solve the same question by applying Pythagoras theorem, and now we will see the question here. Here in an equilateral triangle with the side A, means equilateral triangle, for example ABC is an equilateral triangle and its each side is A. Prove that first altitude is equal to A root 3 upon 2, and second area of equilateral triangle ABC is equal to root 3 upon 4A square. So this part in second question we have derived or proved last year. Now here ABC is again an equilateral triangle having its each side A means AB is equal to A, AC is equal to A, and just now we have seen that BD is equal to BC, BD is equal to BC, and that is equal to 1 half BC, means BD is equal to 1 half A, and BC is also 1 half A. Here now we have to prove the values of altitude as well as we have to find the area of the equilateral triangle. So before we will see that, let triangle ABC be an equilateral triangle having side A and draw AD perpendicular BC. Here we have drawn AD perpendicular to BC. Then just now I have mentioned here that AB is equal to A, then BD is equal to 1 half of BC, that is BD is equal to BC is A, so A upon 2, so BD is equal to A upon 2. Now we have to consider the triangle ADB, and it is a right angle triangle. Since it is a right angle triangle, we can apply Pythagoras theorem. So by Pythagoras theorem we will get AB square is equal to AD square plus BD square. AB square is equal to AD square plus BD square, And now substituting the values of corresponding sides, we will write here AB is A, so A square is equal to, we don't know the AD, so AD square as it is, but BD we know that BD is equal to A upon 2, so A upon 2 bracket square. Now squaring the corresponding values we will get here, A square is equal to AD square plus A square divided by 2 square is 4. Again it implies that here denominator is not same. Again if plus A square upon 4 is taken to left hand side, it will become minus, so we will get here A square minus A square upon 4 is equal to AD square. Here denominator is 1, so for this subtraction we have to cross multiplication and cross multiply, so AD square is equal to 4A square minus A square, 4A square minus A square divided by 4 1 4. So it implies AD square is equal to 4A square minus A square or 1A square, that is equal to 3A square upon 4. And therefore AD, taking square root on both sides, we will get square root of AD square is equal to square root of 3 is root 3, square root of A square is A, and square root of 4 is 2. So AD is equal to A root 3 upon 2. Here we have find the value of height, means altitude, and now we are asked to find the area of the triangle. So we know the formula that the area of triangle ABC is equal to 1/2 base into height. Here that is equal to 1/2 into base is BC and altitude or height is AD. And now substituting the corresponding values, we get area triangle ABC is equal to 1/2 into BC is A into AD is A root 3 upon 2. Here A into A we will get A square. Here root 3 into 1 it will be root 3 and 2 into 2 that will be 4. In this way area triangle ABC is equal to root 3 upon 4 A square.